Okay, so at this point, we've learned two properties of exponents that when we multiply powers, we add the exponents. When we divide powers, we subtract the exponents. Now, what is EEM? So, powers of powers. So, we're going to talk about what happens when we take a power of a power. So, let's look at what this looks like. So, if I have something like x squared, squared. Let's do x squared to the third power. So when I take something to the third power, x squared we know is the same thing as saying x times x, right? But what I'm actually going to even argue and say, I'm going to do this a different way, is that what is saying something is to the third power? That is saying I'm going to multiply something by itself how many times? 3 times. So this is the same thing as saying x squared times x squared times x squared, right? And by the properties of exponents, we know that when we multiply powers, we add the exponents, right? So this is the same thing as saying, I can even rewrite this as x times x times x times x times x times x, right? 2, 2, and 2, 2, 2, and 2. But what we already know is that this is the same thing as saying x to the 2 plus 2 plus 2. What is the same thing as repeated addition? Well, this is the same thing as saying 2 times 3, right? Repeated addition, 2 plus 2 plus 2, is the same thing as saying 2 3 times, 2 times 3. And what is 2 times 3? X to the 6th power. And again, if we write this out, x times x, which is x squared, times x, which is another x squared, times x, which is another x squared, how many x's do I have? 6 x's. So what is the conclusion here? That when we take the x, I'm going to erase this, and now we're focusing on this today. When we take the exponent of an exponent, you multiply the exponents. I know there's a lot of exponent there. So when you take the exponent of an exponent, you multiply the exponents. So, for example, let's just move this down. Let's do 2 to the 8th to the third power. So we have 2, again, has the base ever changed? Even with multiplication, the base never changes. That is really, 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 really important. I wrote it here. The same base, you have to keep the base the same. The base stays the same. The base stays the same. The base stays the same. Okay, so 2 stays the same. And then we just do 8 times 3. And what's 8 times 3? 8 times 3 is 24. Let's do one more. 17 to the 40th power to the 4th power. So this goes to 17. The base stays the same. And then 40 times 4 is what? 4 times 4 is 16. You add a 0, so it's 160. Okay, and also, how do we work with parentheses? So let's talk about if I have something like 3x squared. So if I have 3x squared, then I know that what does squared mean? 3x times 3x. And I'm actually going to rewrite this as 3 times x times 3 times x, right? This is your 3x and this is your 3x. Everything is being multiplied together. So that's really important here is when we're dealing with powers, we're dealing with multiplication, right? Remember when we did exponential functions, they were called the multipliers. So multiplication. And we know with multiplication, A times B times C is the same thing as saying B times A times C, which is the same thing as C times A times B. This is commutative, meaning I can change the order. I can change the order around. So I can move this around. So what I'm going to end up doing instead is I'm going to make it 3 times 3, right? Actually, let's color code this a little bit. I'm going to make my 3's green. So I have 3 times x and 3 times x. I'll keep the x black. So I'm going to change this to 3 times 3. I'm just changing the order times x times x. What is 3 times 3 the same thing as saying? Well, 3 times 3 is the same thing as saying 3 to what power? Squared. And then x times x is the same thing as saying x squared. So what we've gotten out of this is that 3x squared is the same thing as saying 3 squared, x squared. So it's kind of like I distributed that 2 to both of these terms. Now, this is the key here. This property, I'm writing it out because it is crucial, only works with multiplication and division. What do I mean? If I have 3 over x squared, I can also, because this is division, 3 over x is 3 divided by x. This is going to be 3 squared over x squared. This squared gets distributed to both the numerator and the denominator. However, if I have, and I'm going to put this in red here, like bad, don't do this. If I have x plus 1 squared, it is not the same thing as saying x squared plus 1 squared. You cannot distribute it if there is an addition sign or a subtraction sign inside. I don't know if you guys remember, but I have that tweet on my bulletin board that says your MCM thinks that a plus b squared is equal to a squared plus b squared, and then it says do better, sis, because it is not the same thing. These are not equal. And I emphasize it so much because it is probably the biggest mistake that people make. Ah! Sorry, I let my frustration get the best of me. Anyways, moving on. So yeah, if I have something like just really quickly, let's go one more. ABC to the 4th power is a to the 4th, b to the 4th, c to the 4th. Now, what if I have something like a squared, actually, let's do this. 2a squared b cubed. So I know that this cubed is going to go to the 2. It's going to go to the b, to the a and the b. So what I'm going to do is I'm going to rewrite this as 2 cubed, a squared cubed, and b cubed. I use parentheses because this is going to change, right? So I have 2 cubed, which is, we'll change that in a second, 2 cubed, a squared cubed. What happens when you take an exponent of an exponent? You multiply. 2 times 3 is 6, and then b cubed. And if it asks for a constant, a lot of times it'll say write it as k, a to like the x, b to the y, whatever like x and y are. So it'll tell you to rewrite it with a constant here. And so you would do 2 to the 3rd is 8, a to the 6th, b cubed.